You wanted to dive deep into Mercury's mysteries, huh? Well, buckle up because it's a wild ride. I mean, think about it. This planet's closer than some gas giants, yet it's got scientists scratching their heads.
Yeah, it's like, that quiet neighbor you never really talk to? Turns out they've got a whole secret life.
Exactly. And this ESA article, it highlights why Mercury is such a tough nut to crack. There are these unique challenges we don't face with other planets. It's not just a matter of, hey, let's launch a rocket and we're done.
Nope, not at all. Can't just point the Hubble at it and expect a postcard perfect pick. We're going to unpack 3 major hurdles here. The first one, even getting a decent look at Mercury, that's surprisingly tough.
It's playing cosmic hide-and-seek or something?
Pretty much. It's earned the nickname Elusive Planet. Being so close to the sun, you can only spot it at very specific times, right before sunrise or right after sunset. Those tiny windows.
When it peeks out from the sun's glare.
Yeah, and even then, it's low on the horizon. Makes it super hard to observe clearly, like trying to study a firefly that's right next to a stadium spotlight.
Not exactly ideal lighting for a photo shoot. And then there's the whole issue of using big telescopes during the day to see Mercury, right? That's a no-go.
Absolutely a no-go. Sunlight can fry those sensitive optics. So most large telescopes, they're actually forbidden from pointing anywhere near the sun. Too risky.
Which brings us to a pretty mind-boggling fact, the Hubble, that powerhouse of a telescope. It's never directly observed Mercury. Can you believe that?
It's true. The risk of sun damage is just too high. Those delicate instruments. It's like trying to study a snowflake under a blowtorch. Not a good idea.
Okay, so challenge number 1, just getting a good look at our elusive neighbor is tough. But then the next hurdle is even weirder, actually getting to Mercury. It's harder than reaching planets that are farther away.
You'd think closer equals easier, right? Nope. It's tougher to reach Mercury than, say, Jupiter or even Pluto.
Hold up. Pluto, the dwarf planet, way out there. Why is that?
Sun's gravity. That's the culprit. Think of it like, trying to swim upstream, but the current is ridiculously strong. To reach Mercury, a spacecraft has to constantly fight against the sun's pull. You need a crazy amount of fuel.
Which would make the mission budget skyrocket, I'm guessing.
Exactly. So instead, we got to get creative. We use what's called a gravity assist.
Okay, now you're talking space magic. What's a gravity assist?
Picture this. A spacecraft using a planet's gravity to, slingshot itself towards its target. Kind of like bouncing a ball off a moving wall to change its direction and its speed.
So planets become these cosmic springboards.
Yeah, that's a great way to put it. And that's how this mission, BepiColombo, is getting to Mercury. Joint effort, Europe and Japan.
7-year trip, 9 gravity assists. Earth, Venus, even Mercury itself. It's like a cosmic ballet, isn't it?
Yeah, it's pretty intricate. Makes you appreciate how much harder it is to get to Mercury compared to, say, ESA's solar orbiter. That one reached the sun in under 2 years.
Wow, that time difference really puts it in perspective. But these gravity assists, so ingenious. Didn't some Italian scientist, Giuseppe Colombo, come up with that?
Yep, Giuseppe BepiColombo. Back in the 70s, he figured out how to optimize the trajectory for NASA's Mariner 10. Allowed it to do 3 flybys of Mercury instead of just 1. Changed the game for planetary exploration.
And now they've named the current mission after him. What a legacy. But even with these gravity assists, just reaching Mercury is step 1, once you're there. Well, challenge number 3 hits you.
Oh, yeah. Survive it on Mercury, it's no picnic. We're talking extreme temperature swings, like the most extreme in the solar system, sunlit side. Over 450 degrees Celsius, that's 840 degrees Fahrenheit.
Ouch, like sticking your hand in a pizza oven.
Pretty much. Night side. It plunges to negative 180 Celsius, that's negative 292 Fahrenheit.
Wow, so it's a planet of extremes, cosmic sauna on one side, deep freeze on the other.
You got it. And for missions like BepiColombo, huge engineering headache. Imagine trying to keep a laptop running inside that pizza oven we talked about. Normal spacecraft materials. Toast.
So how do you even design something to survive that?
It's all about pushing the limits. Material science, engineering. BepiColombo's solar panels, made of special stuff, can withstand way higher temperatures than usual.
So like super panels.
Yeah. And they have to be tilted at extreme angles too. Yeah. Minimize that sun exposure.
Can't just run down to the space hardware store for those, I bet.
Nope. Actually, fun fact, setbacks in developing these solar panels almost caused the whole mission to be scrapped. Close call.
Wow, that's cutting it close. So what else besides super panels?
Cooling system. Gotta have a top-notch one.
Yeah.
Pipes, radiators, the whole shebang. Keeps a stable temperature inside. Protects those sensitive instruments.
Not your average AC unit, I'm guessing?
Not even close. It's this whole network. Pumps, heat exchangers, working constantly to keep things cool in that inferno.
And I imagine testing the stuff under those conditions, another challenge.
Oh yeah, replicating Mercury's environment here on Earth, making
Mhm.
sure everything works as it should. That's a whole other level of complexity.
It really makes you appreciate all the work, the ingenuity that goes into these missions. Sometimes I think we take space exploration for granted.
Easy to do, isn't it? Especially when we see those beautiful images. But stories like this, they remind you of the challenges, the dedication of the people behind it all.
Right. It's not just pointing a telescope and snapping a pic. It's pushing the limits, inventing new things, just to have a shot at understanding a place like Mercury. So we've covered the first three hurdles, just getting to Mercury. Now, what about the mysteries it's holding? What's BepiColombo actually looking at when it reaches orbit? What are those burning questions scientists want answers to?
That's where things get really interesting. Because BepiColombo isn't just one spacecraft, it's two. It's a tag team effort. We've got the European Space Agency's Mercury Planetary Orbiter, the MPO for short, and the Japan Aerospace Exploration Agency's Mercury Magnetospheric Orbiter, MMO. A dynamic duo, I'd say.
Two spacecraft, one mission. What's the thinking behind that?
Well, each orbiter has its own special set of instruments, and they'll be tackling different aspects of Mercury. It's like having two detectives on the case, but each one's focused on different clues.
Ah, so it's a multi-pronged approach to really get to the bottom of Mercury's secrets.
Exactly. The MPO will be our planetary geologist, getting up close and personal with Mercury's surface, mapping its topography, analyzing its minerals, looking for signs of volcanic activity.
So like piecing together the story of Mercury's past, its geological history.
Got it. Meanwhile, the MMO, that'll be our magnetic field expert, focusing on Mercury's magnetic field and how it interacts with the solar wind.
The solar wind? You mean that constant stream of charged particles coming from the sun?
That's the one. The MMO will be measuring the magnetic field's strength, its structure, studying those energetic particles trapped within it, and trying to understand how the solar wind actually shapes Mercury's environment.
Okay, so we've got these two specialized orbiters gathering all this data. What are the big mysteries scientists are hoping to solve? What are those burning questions about Mercury?
Well, top of the list has got to be Mercury's crazy dense core. For its size, it's denser than any other planet in our solar system.
So it's like this tiny planet packing a heavyweight punch.
Pretty much. Scientists think it's mostly iron. But the question is, why is it so disproportionately large? That's what we're trying to figure out.
So like a giant metal ball just whizzing around the sun. It's kind of cool when you think about it. But this dense core, it's got to have implications for how planets form, right?
Totally. Right now, the leading theory is that, way back when, early solar system, a huge impact might have stripped away a chunk of Mercury's outer layers, leaving behind this dense iron-rich core. If that's true, it could change our understanding of planetary formation.
So Mercury is like a window into a dramatic past, not just for itself, but for the whole solar system.
Exactly. And BepiColombo's instruments are going to help us study that core's composition even closer, hopefully get some answers.
Okay, dense core check. What other mysteries are we tackling here?
Another head-scratcher is Mercury's magnetic field. Now, you might think every planet has a magnetic field. What's the big deal? But Mercury's is different. It's weak, really weak, only about 1% as strong as Earth's. And while we know Earth's magnetic field comes from the movement of molten iron in its outer core, for Mercury, we're not entirely sure.
So it's like a planetary mystery novel. We've got the effect, this magnetic field, but we don't know who done it or how it happened.
That's a good analogy. Could be a partially molten outer core, or maybe it's got something to do with Mercury's unique interaction with the solar wind. We don't know for sure.
So BepiColombo's our detective, piecing together the clues about what's happening deep inside Mercury.
Exactly. That MMO, the Mercury Magnetospheric Orbiter, is going to give us unprecedented data on this magnetic field, helping us understand its origin, how it behaves, all that good stuff.
Okay, so we've talked about the inside, the core, the magnetic field, but what about the outside? That surface, those pictures we see, man, it's just craters everywhere. It's both fascinating and kind of desolate looking.
Oh yeah, the surface of Mercury is something else. Heavily cratered, more so than any other planet in the solar system. All those impacts from asteroids and comets over billions of years.
It really puts things in perspective, doesn't it? Makes you appreciate our nice, protective atmosphere here on Earth.
For sure. But here's the thing. Despite all those craters, Mercury's surface also has signs of volcanic activity. There's these huge plains of smooth volcanic rock, and some scientists think Mercury might have been volcanically active way more recently than we thought.
Wait, volcanoes on Mercury? I always pictured it as this, like, dead, airless world.
It's not as active as Earth or Mars, no, but there's definitely a fiery past there. BepiColombo is going to study those volcanic features,
Yeah.
see how old they are, what they're made of, trying to figure out the story of Mercury's volcanic history.
So it's not just craters and dust. There's a whole story of fire and change etched on Mercury's surface.
You got it. And who knows? We might even find evidence that there's still some kind of geological activity happening today. That's the exciting thing about exploration. You just never know.
Speaking of unexpected discoveries, we got to talk about the ice. Ice on Mercury? I thought it was scorching hot there.
Right. It seems impossible. But that's what makes this discovery so fascinating. Back in the 90s, scientists started using radar to study Mercury from Earth. And they found these weird, bright reflections at the poles.
And those bright reflections turned out to be ice.
You guessed it. It sounds crazy, but those reflections were consistent with water ice, tucked away in those permanently shadowed craters at the poles.
So while the rest of the planet is baking in the sun, these craters are like cosmic freezers, just holding on to this ancient ice.
That's a great way to visualize it. It shows you just how diverse Mercury's environment really is. BepiColombo is going to be looking for more evidence of this ice, trying to figure out how it got there, what it can tell us about the history of water in our solar system.
It's amazing to think that a place that seems so barren could be holding on to such valuable resources. Makes you wonder what other secrets Mercury might be hiding.
It does. And, we've only scratched the surface here. There's another crazy feature on Mercury that we haven't even touched on yet. They're called hollows.
Hollows? What are those?
They're these strange, irregular depressions, kind of like pits or dips. And they seem to be unique to Mercury. Scientists aren't 100% sure how they formed, but one theory is that they're caused by stuff like ice, just sublimating away.
So that's like the ice literally vanishing into thin air.
Yeah, that's the idea. It's one of the many puzzles that BepiColombo will be looking into. And these features, just like the craters, the volcanic plains, they all tell us something about Mercury's history, how it's evolved over time.
It's incredible how much information is packed into every inch of Mercury's surface. It's like a giant cosmic puzzle just waiting to be solved. But I gotta ask, why does all this matter? Why should we, here on Earth, care about what's happening on this tiny, faraway planet?
That's a question a lot of people ask.
Yeah.
And it's a fair one. But studying Mercury, it's not just about satisfying our scientific curiosity. It's about understanding our own place in the universe, how we got here.
So it's a journey of self-discovery, in a way.
You could say that Mercury is like a time capsule, a relic from the early solar system. By studying its composition, its magnetic field, all those surface features, we gain insights into the processes that shaped all the planets, including Earth.
It's like piecing together the story of our cosmic family.
Exactly. And as we keep finding more and more planets out there, beyond our solar system, understanding how planets form and evolve, that becomes even more crucial. Mercury, with its crazy characteristics and being so close to the sun, it gives us a really valuable testing ground for our theories.
So it's a laboratory for understanding not just our solar system, but potentially planetary systems across the whole galaxy.
That's the beauty of science. One discovery can lead to so many more questions, new insights. And as we delve deeper into Mercury's mysteries, we're opening up these windows to the vast universe beyond.
It's amazing when you think about the scale of it all. But let's shift gears for a second. We've talked about the science, the technology, but what about the people behind it all? What drives them to dedicate their lives to studying a place as seemingly harsh and distant as Mercury?
That's a great question. And I think the best way to answer it is to look at the legacy of the man whose name's on the current mission to Mercury Giuseppe BepiColombo.
You know, it's amazing when you think about all the effort, all the people involved in making a mission like BepiColombo happen. We've talked about the science goals, the tech, but it's the human element that really gets me.
Yeah, it's inspiring, isn't it? The dedication, the passion, all those hours, all those people working to make it happen.
Exactly. It's like this giant jigsaw puzzle. Scientists, engineers, the technicians, so many people, each one contributing a piece to make the whole thing work. And it all starts with an idea, right? A spark of curiosity that leads to this whole chain of events.
That spark, it's what drives us to explore, to push the boundaries of what we know. And that's what I see in BepiColombo's story, too. A man who, even during a war, never stopped looking up at the stars, never stopped dreaming of exploring space.
It's a good reminder that, wanting to learn and discover, it goes beyond borders, circumstances. It's like a universal language, brings people together, even in tough times.
And that drive to learn, it often leads to unexpected things. For Colombo was that realization that you could use the gravity of planets to basically slingshot spacecraft. It must have sounded like science fiction back then.
Yeah, like he cracked some secret code of the universe, using gravity to navigate. And now, the mission named after him, BepiColombo, it's like his legacy lives on. Proof of what human ingenuity can do.
It's perfect fit, really. And as BepiColombo makes its way to Mercury, it's carrying the hopes and dreams of, well, so many people. People who've dedicated their lives to figuring out the solar system.
And it's bigger than just Mercury, right? The stuff we learn from this mission, it could change how we understand planets in general.
Oh, absolutely. Mercury is like this extreme world, right? Harsh conditions, unique features. It's a perfect place to test our theories about how planets form, how they change over time. What we learn there, it could apply to planets across the galaxy even.
So it's like a key that unlocks a deeper understanding of, well, the whole universe.
Exactly. And as we keep exploring, who knows what we'll find? More surprises, challenges for sure. Maybe we'll see humans on Mars someday, or missions beyond our solar system. Who knows?
It's pretty mind-blowing when you think about it. But for now, let's stick with BepiColombo. What are the scientists hoping to learn from it? What are the big questions?
Okay, so one of the big mysteries is that super dense core. Why is it so dense? Was it a giant impact way back in the early solar system? Or something else entirely? BepiColombo's instruments, they're going to analyze that core's composition in more detail than ever before. Hopefully get some answers.
So we're talking about like looking into the heart of a planet, trying to understand what happened billions of years ago. Pretty amazing.
It is. And then there's that weird magnetic field. Super weak compared to Earth's. And we still don't really know how it's generated. BepiColombo's MMO, that's going to be studying it, mapping it, seeing how it reacts to the solar wind.
It's like imagine you're watching this cosmic dance, these powerful forces interacting, shaping everything around Mercury.
Exactly. And then there's that surface. Remember those amazing pictures? The volcanic plains, the cliffs, those strange hollows. Each one tells a story, and BepiColombo will help us understand them. It's about piecing together the history of this whole world.
Like a giant time capsule holding clues from billions of years ago.
You got it. And hey, maybe we'll even find signs that things are still happening on Mercury. Volcanoes or those hollows, maybe they're forming right now. We just don't know.
It really makes you realize how much there is left to discover. And with each new discovery, our picture of the universe gets a little clearer. But it's not just about the science, right? Space exploration, it's got this deeper meaning for us.
Definitely. It's about pushing the limits of what we can do, what we can know. It's about inspiring people, to dream big, to reach for the stars, literally. And I think it's also about remembering that we're part of something so much bigger than ourselves. We're connected to this vast universe in ways we might never fully understand.
It's a humbling thought, isn't it? And sometimes it's not about the grand discoveries, but the smaller things, the work that goes on behind the scenes, all those people making these missions happen, the engineers, the technicians, the scientists, they all contribute to this amazing journey of exploration.
It shows you what humans can do when we work together, right? We can achieve incredible things. And exploration, it's not just about reaching faraway places. It's about discovering the potential within ourselves, too.
I love that. So as we wait for BepiColombo to send back its data to reveal more secrets about Mercury, let's not lose that sense of wonder, that curiosity, that drive to learn and understand.
Keep looking up at the stars. Keep asking those questions. Never stop exploring. That's what it's all about.